In addition to doing analysis of your optical system, you can use ASAP to render the system geometry, the ray traces, and the light sources so you can get a physical feel for what's actually happening within your optical system. So let's take a look at a system that consists of some very basic geometry, a complex source, and a ray trace, and let's take a look at the information we can get in ASAP. In this particular case, we're just going to draw a light pipe and an LED and then propagate some rays. And I'm going to accept all of the default values here. We now see the geometry of our light pipe and our LED. Now we'll start looking at the results of the ray trace. What we see through the ray trace analysis is that many of the rays are indeed propagating via TIR through our light pipe, but many are being lost either due to the inefficiency in the connection between the LED and the pipe itself, which is why we would often epoxy the LED directly or enclose it within a volume so more light gets directly coupled in. We also have some leakage at the bend due to the fact that the TIR condition is not always met. What we'll also be able to do in the end is do analysis that tells us how much light actually makes it through the fiber. We could also have put detectors in other locations to determine where the energy went. We could also calculate how much energy was actually input into the inside face to get an idea of how much was lost from the LED simply not coupling efficiently into the fiber. And now we see information about the output at the end of the optical fiber with an isometric plot as well as a contour plot. But the picture probably just shows it best that we are getting our energy through, but this is certainly not a uniform distribution of energy, either in angular or positional space. Notice the high concentration of energy at the top with a slight concentration at the bottom. And if we look back at our plot, we see the same type of information presented in our plot.